Okay, yeah, let me first start with an introduction a little bit into the topic of why we should be analyzing policy debates or political discourse as networks. And then I'm going to talk a little bit about software, then about how to construct those networks. And then I will talk also about how to analyze the networks that come out of the software once you have coded and exported those network data. So let me start with a working definition of what I understand a policy debate to be. And this is just a working definition. You may agree or disagree. It's a nominal definition. Definitions can be wrong. They can be useful, more or less useful. This definition here entails that policy or political actors make public claims conditional on each other. Now, political actors would be interest groups, legislators, civil society actors, government agencies, and anyone who has an interest in influencing public policy. They make public claims, so they do that in the media, maybe in the parliament, maybe in other arenas, maybe on social media. This is important because the things they say must be in some way visible to other people to respond. Otherwise, it's not a debate, right? If everybody says something somewhere at home, that's not something other people can perceive. So there's not going to be a debate by definition. They make claims, and these claims are normative statements. They talk about their policy beliefs or arguments or frames or whatever you want to code. So they talk about these things in a normative way. Policy instruments depends on the theory you want to operationalize. And they do that conditional on each other. And this is the important part. This is why networks are a good approach to analyze these things. So when I say conditional on each other, that means actors perceive what other people said before in the debate, and they can respond to this. And they do so not in an entirely random way, but there's a structure to how they do that. And that's why this can be interpreted and modeled as a network phenomenon. So policy debates are complex, dynamic networks. They change over time. That's why they're dynamic. They're complex. That's because the ties of the network aren't just depicting group memberships or similar things, but actually who adopts claims from whom, for example. And there are different kinds of forms of dependence in these policy debates as networks. So for example, reciprocity. Let's say if one actor speaks up, this is often a response to somebody else. And if that pattern happens several times, that can be called reciprocity. So let's say, for example, you say something about a certain policy instrument, and then I respond by supporting what you said, or maybe rejecting what you said. And then you respond again to me in the debate, and then I respond to you again. That's reciprocity. And then triadic closure. So actors form coalitions in policy debates. So if I agree with you, for example, on something, and you agree with him, for example, on something, then probably we will also agree on other things. So there's triadic closure. And this triadic closure leads to coalitions, because if you scale it up in the network, lots of these close triangles where three people agree on similar things, they will lead to a cluster, basically, inside the network. There can also be repulsion of those coalitions. So you can imagine, we could call this negative reciprocity. So you can imagine if we have these coalitions in the policy process as clusters in the network, that while within a coalition, we would reiterate what we say and support each other without any conflict, or at least not so much conflict. You can imagine that if somebody from a different coalition says something, then I'm more likely to talk about the same thing, but in a negative way, if the other person talks in a positive way, or vice versa. And so there's going to be repulsion of these coalitions because of this. There can be path dependence, so concepts are sticky or policy beliefs are sticky. If I talk about something, then there's a certain chance that I will talk about the same things in the future. So these concepts carry over to future time points. And there can be something like activity bursts or preferential attachment or popularity effects. This actually has direct connections to the political communication literature, like political waves or issue attention cycles, for example. So the commonality here is that once a topic, in the sense of certain policy beliefs or concepts, once they become popular because people start talking about them, there's a bandwagoning effect. So people then also talk about that thing until it becomes really popular, but then that popular goes away again. So you can see that with these waves you see here at the bottom of the page as an illustration. So lots of different things we can observe in these networks over time and how they unfold. And we can actually then start modeling these things in these temporal networks that we get out of that debate. Now, why should we do this? Why should we try to understand how policy debates work? Well, they're ultimately important to understand policy making. So if you look at that paragraph sign there on the right, that is just to say policies are the outcome of all of this. And when I say policies, this means variation in the sense of which policies are adopted and which aren't adopted as an outcome of a policy debate and policy network processes more generally, or it can just mean variation in what the legislation looks like that comes out of it. Maybe it has certain provisions, but maybe not others. And policy debates are basically an intervening variable or an intervening process between the things on the left you see here, like policy beliefs that are, let's say, more like deep core beliefs that are fixed, maybe resources that actors possess, maybe institutional setups in a country or in a polity, maybe what public opinion looks like. All these things condition how those networks produce outputs, policy outputs. And there's not just one layer. So policy debates can be one layer in that network, but there can be additional layers, additional relations between actors in that complex network. So for example, who exchanges information with whom, but also the organization of common roundtables or policy forums or these kind of things. So it kind of very well fits into the wider literature on policy networks, because discourse then becomes one activity that these actors engage in, and you can connect that to these other activities like information exchange, coordination, and whatever. And then this basically turns into a complex multi-layer network in the sense that these different layers can also influence each other, because if I tend to repeat what somebody else says in the debate, then I might as well seek an information exchange tie with that actor, or vice versa, right? So you can already see that there may be connections between these different layers. The question then is, how do these different layers of that multi-layer network, how do they collectively produce those policies that come out of it on the right? And well, there are different approaches in the literature to answer that question. Some people look into the dominant coalitions that exist in a policy process. So if one coalition is dominant, maybe that translates into the policy. Now, what does dominant mean? We can operationalize that in different ways. Maybe it's certain actors that are central in those networks that monopolize on resources and power in those networks. Maybe it's an issue of contagion of policy beliefs with policy beliefs. So if I am active in this certain policy arena, maybe I learn from other actors how the problem is best tackled, and so those policy beliefs diffuse basically between actors. They travel. Now, which one is the definitive truth? I would be able to say this is active research. Discourse network analysis gives you basically a toolbox for analyzing these processes. So you can look at the different layers, you can look at the relationships between them, you can operationalize debates, you can then apply whatever network analysis method you would like to those networks to understand what policies come out of this. Okay, so in order to make this happen, I have created a software. It's called Discourse Network Analyzer, in short DNA. And this is freely available. You can download it from GitHub. It's a jar file because I created it using Java. So if you have Java, at least version 11 installed on your computer, on any operating system, I think not on Android and not on other phones, but most operating systems, then you can just double click that jar file and you can open that software. And that software has two purposes. First one is to assign tags to text data. So you basically load in text data and then you annotate who says what. So which actors mention which policy beliefs in what ways. So you annotate that. It's like qualitative content analysis, right? And then the second purpose is once you've done this for a corpus of text documents, let's say news media articles or social media like tweets or something, or whatever sources you have where these actors talk about their policy beliefs. Once you've done that for a batch of documents, you can then convert these structured data into networks, into different kinds of networks, depending on the purpose of the analysis. And I will talk a little bit about what those networks look like in a few minutes. So this is what the software looks like. So you can see here, in the upper part of the window, you can see all the documents that are being coded. So these, in this case here, this is the minimum unit pricing for alcohol debate in the UK. So you see the different news media articles from, as you can see here, different newspapers. And if you click on one of them, on one of these newspaper articles, the text will appear down here. And then you see all these yellow text portions here. These are called statements. A statement is a text portion where an actor talks about one of those policy beliefs that these actors can hold. And so a statement is basically a container for multiple variables that can be coded then. And if you click on one of these yellow text portions, this little pop-up window here will show up, and you will be able to code which person is speaking here. Also, the organization the person belongs to, let's say in this case, Ian Gilmore from the Alcohol Health Alliance, and then the concept the actor is talking about. So the concept is an abstract formulation of that policy belief, something that can be coded across different statements, to relate the actors to each other in terms of what they say. So the task of the researcher then is to basically develop this coding framework where those concepts make sense and are as orthogonal to each other as possible to capture the contents of laws that could come out of this process. Then there's a variable down here. It's a binary variable called agreement. And this agreement variable just codes whether the actor supports the concept or rejects the concept. And this is of course important because if you don't code this part, then you would put two actors into the same coalition who actually say the opposite of each other. So one of them agrees and the other one disagrees if they just are connected by topic affiliation. And then here on the right, you see a statement navigator. So you can also click here on all those statements and it takes you to the document and opens up that pop-up window. You can filter. There are lots of additional features hidden here in the menu. So there's coder management. You can set up an online database on the server, let's say MySQL or some other database. You can also work offline with file-based databases on your computer. But if you have a team, you can do this collaboratively in real time. And then you can, while reading, you can highlight some text portion, right-click and say format as statement, and then it creates one of these yellow text portions there, and you can add the data to the window. So the question was whether it takes into account time. Well, not within a document, but you can see here that these documents have a date and timestamp. And so you basically code when that article was released, when it was published. And so that's how the temporal dimension gets into the analysis later. So you don't code it down here, it's coded at the document level, but it's used for the analysis. Okay, so once you've done all of this, you click on export in the menu and it opens a little window that gives you lots of options for exporting those networks. And so these are all settings basically to define what that network looks like. So for example, you could export a one-mode network. That means there's only one type of node in the network, for example, actors. Or you could export a two-mode network. That means you export a network where you have both actors and those concepts as nodes, and you can look at the connections between them. And you can set up many other settings like the file format, depending on what network analysis package you want to use to analyze the data. You can set up which variables you're going to use in the analysis. You can normalize the data. You can exclude certain actors and concepts and other things. You can reduce the time span that is exported so that you can export multiple consecutive networks as well, and so on and so forth. And once you press export, you will see something like this. This is just one specific kind of network that could come out of this. This is based on the minimum unit pricing for alcohol debate in this case. In this case, that's a one-mode network. It's what I call a congruence network. And in this case, that means that all these nodes here are actors who speak up in the debate in the newspaper, in the newspaper-based debate. And you can see that these actors are connected by ties, and these ties represent how strongly they agree on the policy concepts they use, on the arguments or frames they use. So you can see that some actors are more strongly connected. They form coalitions or clusters in the process. And you can then analyze the networks that you see using, for example, graph clustering techniques. They can do community detection. And what you see here, those blue hyperplanes, those bubbles, that is the outcome of those techniques. So you can identify those clusters. They're shown here in blue. And there are different techniques you can apply, for example. And then you can look at what that looks like over time and how it changes, who's leaving their coalition and who's joining the opponent, for example. And you can use that to track your policy debate over time. You can also look at certain organizations in their role, maybe because they're in the middle, they're connected to both coalitions. And you will find that most of the time, these are going to be organizations that have members. Like, for example, here in the middle, you see the Conservative Party. Well, that's because it's a large organization and there are many different people in it that ties to different stakeholders. Okay. So I have also created a package called rDNA. That's an R package for connecting the Discourse Network Analyzer to R, and then you can interact with it. You can call a function called DNA network that is shown here, and you can set all the different options that you saw in this export window. So it's the exact same options that you could set there graphically. You can use them here in this function as well to get those networks directly into R. And you can then plot them, analyze them, and so on. So it has more analysis functions than the software DNA itself. Now, I recently rewrote the software, and the rDNA package is still kind of work in progress. But at this point, if you really do need this package, then you can still use the previous version of DNA, do whatever you need to do with the rDNA package, and then upgrade the database version later to version 3. The other purpose of this package is also to facilitate data exchange between a DNA database and R. So you can basically say, okay, let's take let's say LexisNexis tools package that one of my former research assistants created helpfully. And you can batch download articles from that database, and you can use the LexisNexis tools package to put them in the right shape. And then you can put them into a data frame and move them directly into the database from there. So that means it's easier to do the data exchange. You can also use it as a complete remote control. You can code it in R if you want, but that requires you to know where in the text text position you've got the statements. Well, it's all possible, but of course the graphical user interface exists for a purpose, and that's because it makes it easier to code. Okay. Now, while I don't want to talk about software all the time, the most important thing is how do you construct those networks once you've coded them? So what is underlying that export window? And actors. These actors are the actors you see in those little pop-up windows. The actors you coded, right? So this is a collection of them as nodes in the network. Then you see the concepts. These are the concepts you also coded in the software in those statements. Then, of course, very simply, you can connect the actors to the concepts that these actors use. So if an actor talks about a certain concept in a statement, you just connect them. Call this the affiliation network. That's a word that is synonymous with a two-mode network or with a bipartite graph in the networks literature. It's all the same. That just means there are two types of nodes, and you connect them between each other. But there are no connections between the actors because we're not defining what that relationship could look like. And there are no connections between the concepts. The only thing we care about here in this affiliation network is the connections between the actors and the concepts. We can create some sort of map. Now, the problem is this gets pretty complex if you do this for any reasonable empirical debate. So you can imagine if you code something with several thousand statements, all you will get out of this for this network will be like a hairball. You won't be able to see any real structure anymore. It also doesn't allow you to see those coalitions properly. So in your head, you will always think, okay, now let's say actor 1 and actor 2 are connected both to concept 1. That means they should be in the same coalition, right? And so you try to see who's connected to the same concepts, and then you try to somehow put them in the same coalition. But that's of course quite onerous, and that doesn't work so well. And so you can then instead use these data here, these networks, and you can infer the similarity in terms of tie profiles between these actors instead to look at this more directly. You could create an actor network. And this is what we care more about than those latent connections between them. Well, actually, these are the latent connections, but we care more about them than those connections to those concepts. Because at the end of the day, most theories are related to actors, right? So the advocacy coalition framework or many of those policy theories that float around, they're about actors and the coalitions they form. And so let's say here, actor 1 and actor 2 both refer jointly to concept 1, maybe with some time in between. That means they get connected in that network. And now let's assume for a moment that actor 1 and actor 2 both talked about 30 different concepts in the same way. So they share 30 different concepts. So what's going to happen then is that these two actors will still be connected, but they will have a tie weight that is proportional to 30. To the number of concepts they share. Okay, and now you can do the same thing with concepts because there are also many theories or theoretical approaches that care more about the concepts than the actors. That's actually a weird bifurcation of the literature on political discourse. Some people care only about things like, I don't know, how does this debate make use of the concept of justice or something like that, right? They don't care about actors. And then, or what different kind of schools of thought or ideologies emerge or frames emerge from the literature, from the debate. They don't care so much about the actors. And then others care only about the actors, depending on the theory and the field, right? And so you can do both or either of them. If you care more about the actor networks, well, export the actor networks. If you care more about the concepts, well, look at the concept network. So in this case, for example, concept 1 and concept 3 are both used by the same actor, actor 2, and that connects these two concepts directly. So you can then look at this as a map, like an ideological map of the debate. And and then you can also try to identify clusters of similar policy beliefs that belong together and that form some sort of coherent unit of argument or, well, ideology, right? But not so fast. We also need to take into account agreement and disagreement. So you will remember that in the software, you saw this little binary variable agreement, yes or no, whether the actor agrees or disagrees with the concept. And we need to use this here. We need to qualify the network type instruction by using that variable. So we can explore two different kinds of networks based on this. First one is a congruence network, and the second one is a conflict network. Congruence network means that the first actor and the second actor in any part of the network both in a positive way refer to that concept, or both refer in a negative way to that concept. And that means they get connected or their tie weight is increased. Now, this is obviously aggregated across the whole network. So basically for actor 1 and actor 2, we simply count over how many concepts do they both agree or both disagree with the concept. So we aggregate this. And that way we construct the whole network. And we can also export a conflict network. So we could say, well, actor 1 agrees and the other one disagrees. So there's a conflict between them. We can infer a conflict between these two actors, or vice versa. Yeah. So we aggregate this into a conflict network, depending on what we want to analyze. We could also take that congruence network and we could subtract the conflict network from it. If you do that, you will get a signed weighted network. Signed means can have positive or negative values on those ties. So positive ties would mean there's more agreement than disagreement between any two actors. And negative ties would mean there's more conflict than agreement between actors. So it's some sort of standardization. So there are different ways to do this. But there's still a problem if we do it this way. And the problem is that we need to normalize the data. So if you look at this network here that is shown on the screen, then you will see, well, that doesn't really show me anything because that's a core periphery structure, right? So there are no coalitions. Where are the coalitions? Well, this is the German pension politics debate for 6 months in the year 2000, January to June. And this is a congruence network and it's not normalized. And now what happens here is that we have all these gray nodes in the middle. And these gray nodes are very central. They hold together the network. These gray nodes are mostly parties and also some federal ministries. So pretty big, important actors that make a lot of statements and who also have many members with potentially diverse viewpoints. Yeah, so you can imagine the Social Democratic Party will have, I don't know, like a more kind of left-leaning wing and a more right-leaning wing or moderate wing. And you can imagine they will connect to all different parts of the network in terms of agreement. Now, this is exactly what's happening here. And so basically this is turned into a core periphery structure by the centrality of those important membership actors, these mediagenic actors. Now we can correct for this very simply. We can simply take every edge weight in this network, and we can just divide it by the average activity of the two actors adjacent to the edge or incident to the edge. So let's say we've got this actor here, the red one here on the right. Let's say this actor makes 40, like statements about 40 different concepts. And let's say this yellow one here makes statements about 20 different concepts. The average of that is 30, right? So we just take whatever the edge weight is between them and we divide it by those 30. And it's very simple normalization, transformation. And if we do that, this simple transformation, then that same network looks like this. And suddenly we can see the different coalitions showing up in the political process. So we see a coalition here on the left, where mostly these parties and government organizations are located, and also lots of red nodes. These are social interest groups and trade unions. And then we see this other big coalition on the right, which has many blue nodes, for example. So these are banks and insurance companies, and also several yellow organizations. These are employers and industry associations and liberal organizations. So it kind of makes sense now. So normalization can be important if our goal is to find those coalitions. Now you could say, well, but it's a feature of the data. I don't want to delete it. Do I really have to? Well, no, obviously not. It depends on what the goal of the analysis is, right? But it's an option you have if the goal is to look at let's say profiles of policy beliefs rather than who is most active. If you don't want to conflate these two things. Okay, I'm going to give you an example, like basically this example, just in more detail. And after I'm done with the example, this is going to be a descriptive example, so to say, right? So I'm going to describe what that debate looks like over time and what you can see there. After this, I'm going to show you how to then analyze the data also using inferential techniques, so regression analysis basically, but for network data. And so this kind of speaks to two different kinds of potential users. What I'm going to show first is basically the ideographic approach, right? So I'm interested in this particular debate because I care about the topic. So how can I analyze this debate and what can I learn about the debate, about how it's structured and changes over time? That's that approach. And after this, that approach is more about, okay, I don't care so much about this particular debate. It's an approach where I care more about learning about debates in general. I want to abstract from it and understand the underlying mechanisms and processes that guide how that debate forms over time. So I'm going to do this first. Okay, so German pension politics, I analyzed this from the early 90s to 2001. And I did that because in 2001, there was a major policy reform. And that reform was the Riester reform. It introduced a 3-pillar pension system. That was, even though the most important pillar was still the pay-as-you-go system, just as before, the literature said this is really a major paradigm shift because it introduces these 3 pillars instead of 1, and that is basically a gate into expanding the privatization component in pension policymaking, or in the way the pension system is handled. And the question was, how could this come about? Why did this happen? And of course, any descriptive analysis cannot conclusively shed light on why exactly it happened in terms of a causal relationship. But what we can do is look at the discursive level, how the debate around pension politics changed over time to perhaps provide one layer or one lens through which we can look at this process. So there was widespread agreement between actors in the 1990s on the need for a reform. Problem was, due to demographic change, the pension system was under pressure. There was not enough money in the system. So people were discussing, how do we solve this? Some organizations said, well, we need to keep the pension system as it is in principle, but we need to find ways to make it more sustainable. So for example, we could strengthen or introduce fertility-related measures. We could, for example, use parenting times and give some sort of subsidy that is used for the pension system, like for later on in life. We should reward producing offspring. Because if people have children, these children will then later on pay into the pension system. And when they do, that basically fixes the financial problem we have in the pension system, because we have more workers to pay for the old people, right? So different kinds of fertility-related measures, but then also strengthen the insurance principle. That's another thing. So basically, instead of incentivizing families, we take elements out of the pension system to reduce it to an actual insurance. So for example, we take out pensions for widows, for students, for military staff, and so on and so forth, to reduce it to its core, and thereby we save some money. So that's what some people said, but using different policy proposals. Some people said, well, it's more like a labor market issue. If we can only fix the labor market and more people work, and that means more people pay into the system, so no financing problem. And some people said, well, we could cross-finance it through immigration. Well, not cross-finance. We could boost immigration, and then if we have more immigrants, they could all work, and then they could, pay into the pension system, and problem solved. And a demographer calculated that you would have to let 175 million people immigrate to offset the financial problem. So the debate around this died off at some point then. And then, of course, another possible pathway was to do a transition to a capital cover system. So it's no longer the case then that people pay money into the system and it gets taken out immediately for the pensioners, but people save for their own retirement for later on. And yeah, a number of different concepts are associated with these proposals. Now the literature says at the beginning of the 1990s, there was a consensus as to how the pension system should be designed. Basically, everybody was on the same page. It needs to stay as it is. Maybe we can make some minor amendments. So basically, there's 4 points here. The question is then, how and why did this pension consensus erode And can we see that in the debate? So can we make this visible, this shift in the debate? And so more generally, can we make a transition between different policy paradigms visible? So here are some of the possible solutions that I then coded in the DNA software. So you can see, transition to a capital cover system, private saving, increasing the labor force through immigration, also gender equality. Well, I have to put it in quotes because they sold it as gender equality, but what it means is if more women work, then we fix the pension system. So they didn't really care about gender equality in that sense. Work incentives for any other person who doesn't work, basically. We could decrease the pension level. So if we cut it at the other end of the, the part of the system where the expenses occur, that could also potentially solve the problem to some extent. But of course, it will make people poor in their pension age. Introduction of uniform pensions, decreasing the old age dependency ratio by shortening school education. We actually did this from 13 to 12 years of secondary education, primary and secondary education. Because people don't go to school for so long, they enter the labor market earlier, and that means they have more time to pay into the system. Increasing the pension entrance age, that was done as well to 67 or so. Voluntary work after retirement. One proposal was to link a person's pension level to his or her number of children as a reward for producing children who would then pay into the pension system. And various other fertility incentives. So I was at the Max Planck Institute for Demographic Research when I carried out the research. So this was really interesting for everyone to see then. So I coded newspaper articles from a big German newspaper, the Frankfurter Allgemeine Zeitung. Now you may say, why didn't you code multiple newspapers? Well, this was my first case study, and I wanted to have a case that is as complete as possible so I can look at changes over time. And there was just so much happening that I couldn't possibly code more. So the method didn't exist before I did this. Before I wanted to get it right with one source. That was more important than having less media bias by looking at only one source. But in subsequent research, I looked at more sources than one, of course. So I coded 1,879 articles with 7,249 statements between 1993 and 2001. So that was a lot of work. I had a research assistant to do some of the work, checked intercoder reliability. There were 461 individuals from 246 organizations. I coded 68 policy instruments or solution concepts, some of which you saw on the previous slide. And so I first tried to come up with a deductive coding framework. So I basically read all the economic literature on how to design a pension system. And I created this coding scheme. But then it turned out that actually politicians talk about a lot of stuff that is not in the literature. And so I had to add 48 new concepts. It may be better because you try to come up with this theoretically, but it's often not feasible. You have to do a sort of inductive approach because you can't possibly discover those concepts by just looking at the literature. So you need to go back and forth a little bit then to get the coding framework right, adjust it, multipass coding, these kind of things. Okay, and then, so this is just frequency distribution. There was an election campaign in 1998 as well. You see there's some activity at all time points. I didn't include 1993 to 1995 here in this diagram. Also, the analysis I'm going to present starts in 1997. That's when the debate really took off, when more activity was there. So before 1997, it looked pretty much like in 1997, but less activity. Okay, now first, before I show you the different years, I'm going to show you the cross-section of the whole network. So let's say I take the data from 1993 to 2001, to May 2001, when the policy was adopted in the parliament. And I lump this all together in one network. This is going to be a congruence network, and it's going to be normalized. And when I do that, I can impose a threshold value on the tie weights. So that means if I impose a value of, let's say, 0.8, that means I retain only those ties that have a weight larger than 0.8. And I delete all the, let's say, low weight ties. So I retain only the most intensive edges. So that's what I did here. And I will gradually lower that threshold to show you what the implication of that is. So we start out with a high threshold, and that means we discover these little islands, the core components of the different coalitions that we're about to discover. And you can see that on the right, you see these two clusters already with lots of yellow and blue nodes. So banks and insurance companies and employers and industry associations. And why are there two of them and not one? Well, that's because they favor two different kinds of saving. So one coalition is into real estate, and the other one into life insurances and other saving products. Then you see this, this cluster predominantly composed of gray nodes. This is what the literature called the pension consensus, the dominant policy coalition. So basically parties, government agencies, and then also two yellow nodes and two red nodes. These are the peak trade associations and the peak employers associations. So basically a corporatist system. Okay, and then lots of smaller like single nodes and small companies. That's not so important here. Now let's go down with that threshold value to 0.6, and you see how those two initial coalitions get connected and they grow. And then you can see that this policy consensus that's here on the left and here, how that grows as well. Then you can see this other coalition here and this other coalition here emerging. They're on subtopics related specifically to the topics that they care about. And let's go down from 0.6 to 0.5, and you see how the different parts grow, and then they also grow together. And then now, in addition to that main distinction here between this coalition and these two coalitions down here, we also have these employers associations and these trade unions here. So you can see that we basically have two sort of dimensions in that debate. One is more about employers versus trade unions and issues specific to them. And then the other one is more about privatization versus keeping the one pillar system that we had. And then we go down to 0.45, and you can see it gets more crowded. And then the coalition down here sort of docks on to this. And 0.35. Now you can see basically that this grows more and more complex the lower we go, up to the point where the complexity doesn't let us see anything important anymore. And so this is basically a case where you can't go too high, because then you filter out important information, but also not too low, because then you see the you see all the trees but not the forest anymore. Okay. Now let's go to 1997 then. This is when it wasn't very political yet. So in 1997 you see all those parties and government ministries like BMAS here in the middle. And then you see some red nodes, the trade unions and social organizations here on one side of it mostly, and those yellow nodes mostly on the other side of that co-referral structure. And that's pretty much like a corporatist setting, right? So we don't see any negotiation taking place here. Okay, fair enough. But we do see that in principle, there's not too much disagreement. They're sort of led by the general consensual line here. Now, we also see those blue nodes, the banks and insurance companies and their interest groups. We see them here and down here, here and here and here. So basically everywhere scattered all around the main component of the network. And okay, so that's the picture in 1997. Now let's go to 1998. We see, oh yeah, by the way, you see this is also thresholded at an appropriate level. Now in 1998, we see how suddenly this thing gets more polarized. So we see how we see this coalition here, which is basically most of the members the previous main component from that core. And then you see how the banks and insurance companies and also employers associations and liberal associations kind of merge here into a coalition, and then some smaller coalitions, but that's just a matter of the setting the threshold right. And it makes sense that the blue and yellow nodes go together because story-wise, because well, if you can sell pension products, then of course you want to get rid of the dominant pension paradigm and you want to have a privatization component. But also as an employer, you want to get rid of those non-wage labor costs, that is the pension contributions. And you want people to save from their salary into their pension product, right? So it makes sense that they go together. Okay, that's 1998. And then I'm going to skip 1999 because it's kind of the same thing. I'm going to go to 2000. And you can see over time it polarizes more and more. Coalitions get more and more coherent internally. So that means it's much easier to find them. So this one was previously on the left. So you can see the actual position on screen doesn't matter. It's just about the connections here in the network. And then, yeah, this bifurcation here into those two subparts of this coalition. So these are into real estate and these are into other kinds of saving, but there's some overlap between them here. These are the associations basically for all the banks, insurance companies, and also some DIA. I think this is a research institute that is funded by banks and insurance companies. So, of course, one could argue, well, that threshold value should be constant over time so that we provide the same opportunity for those coalitions to emerge. But the problem is the debate doesn't have constant activity over time, right? So if there's more happening in a particular year, let's say 2000, then you need to filter out more of the edge weight in order to make it comparable. And so you need to sort of do that to get to the right level on this kind of trade-off that I was showing before between too high and too low to make it as comparable as possible. But you're right, there's some arbitrary component in here. Now, what you can do is, instead of relying on the visual aspects here, you can just apply cluster analysis or graph clustering, community detection. So there are actually ways to find those coalitions, and they can take into account those edge weights. So you don't have to dichotomize it. You don't have to cut it off. You can feed the complete network with all the weights into those algorithms, and they will show you basically the real solution. It's just not as good for storytelling as showing the networks behind them. If you show the dendrograms or whatever comes out of it. But I verified it, and it's in keeping with that. If you analyze it without having to set a threshold value using community detection measures, you will find that it's getting more divided, more polarized over time. You can actually see that also. So I did that in the book I wrote. Also, you can look at that. Here I'm just showing the networks because it's easier. Here you can see that some actors left their coalition and joined the opponent. So for example, the Social Security, SB, left its coalition, joined the opponent. So that happens too sometimes. So this is something, it's like a diffusion process that happens between these coalitions here during those years. And then you see 2001. And you see, this is pretty much the picture we saw in 1997, just reversed. Now we see that the blue nodes dominate this network, and you see the central members of the previous coalition now located here and here and here and even here between these two wings. So basically, it was the transition from one stable policy coalition to another that was replaced through this polarization process that took place in the middle. So the question is, does this happen in lots of social policy reforms? Right? Does it happen under specific institutional settings? So these are now follow-up questions that one could tackle. You can also cluster the concepts and relate them to the different coalitions. I'm not going to go into too much detail here because I will be running out of time. Now I'm going to look at the sort of modeling aspect of this. So understanding going away from that specific network, but understanding the mechanisms behind the unfolding debate. So it's about explaining and predicting discourse networks. So the modeling strategy is a stratified Cox model with a dynamic risk set. So those of you who are into survival analysis will likely recognize this as a discrete survival model. It can be estimated using conditional logit, so fairly easy to estimate actually. It's just quite big if you have all the data in there, including the non-events that don't take place. So basically you model for each day in the debate, what is the probability of seeing a particular actor concept agreement statement, so a combination of these things, over all the combinations that one could have observed instead. So why this one? You can have then covariates for the different actors or concepts for past things that took place. And this is where you integrate network dependence, so higher order network mechanisms into the model. So the time points are conditionally independent of each other, so you can throw them into the model, given the network processes that you're operationalizing over the past event sequence. So you have to create certain statistics, certain counts that operationalize things like positive or negative reciprocity, concept popularity, or things like that. You can count these things and you can include them as covariates in the analysis to account for these things. Then you take the joint likelihood by taking the product over these separate probabilities, and then you've got it. And then you get estimates basically for the different higher order mechanisms, but also for the covariates for the nodes, or for the actors, or for the concepts. Yeah, so I would go into more detail here. I also teach survival analysis at Essex, but this would go too far. So those of you who know survival analysis, they will probably understand what this is, but yeah, would be too much otherwise. So here are two examples of higher order mechanisms. So when I say higher order mechanism, this is how you could think about these things. So let's say you observe at any point in time, you observe the past debate. Then you basically have to ask at this point in time, what is the probability that actor A makes a positive reference to concept B? So A is here, let's say in the upper left corner, A is considering, should I mention concept B in a positive way on this particular day? So what is increasing the probability of that happening, or what is decreasing the probability of that happening, or the log odds of that happening actually? Relative to the other things that this actor could have said, or relative to other actors who could have spoken, or combinations of these two. And you can form, for example, a covariate that includes positive reciprocity. Positive reciprocity means if actor A previously referred, let's say, to concept J1, and previously another actor I1 also referred to J1, also in a positive way, that means A and I1 have some sort of positive congruent past history. And now if I1 says something positive about B, that might be a cue for actor A to also make that positive statement about B. For actor A to make that positive statement about B. Or the same thing negative, right? So if A and I1 both disagreed with concept J1, that's the second column now, in the past, and I1 said something bad about B, then A might also say something negative about B. Or it could be mixed, right? So in the past, they both said no to a concept, but the other node says yes to another new concept. That means A might also say yes to that concept. And so there are different combinations and possibilities. You can aggregate them all into one statistic and count how often this happens over the past event sequence. And you can weight it by time in order to make sure that more recent things are more important in those covariates. So that way you can estimate a coefficient for this positive reciprocity behavior. You can do the same thing with negative reciprocity. That's the second row. So basically repulsion, if you will. You could say A and I1 disagreed previously. That's the first column, second row. They disagreed previously. So A said yes, and I1 said no. And now I1 said in the recent past no to concept B, then A might be inclined to support concept B to maintain this congruence or this conflict actually. And so on and so forth over the remaining columns. So bonding, first row, positive reciprocity, and repulsion is the second row. And you could also have other kinds of mechanisms. You could have something like bonding and bridging. So bonding, that we already talked about this before, but now it could also be aggregated over different in different ways. So you could say, well, if there are many actors with whom I had minimal agreement in the past, and if many of them make a positive statement about B, then that makes A more likely to also talk about B in a positive way, for example. And so bridging. So you may not have a lot of commonalities with other actors. They may be from a different coalition or somewhere else in the network. But if so many people say yes to that thing, then that may be a good thing, right? So that's bridging. Okay. So basically, at any time point, let's say at the last time point here, we have to ask this particular statement that's being made. How do we explain that relative to other things that could have happened? And in asking that question, we have to downweight using a decay parameter or a decay factor all the previous things that happened in the debate previously. Because imagine that something that happened 5 years ago or even 15 years ago informed you to the same extent as something that happened 3 days ago. That would clearly be a very unrealistic scenario. So you want to have some decay functions so that what happened recently is more important. And something that happened in the distant past is not so important. So this is just one formulation that has a half-life parameter, T1/2. So you can set that half-life parameter. I'm currently working on a way to endogenize this thing as a hyperparameter using Bayesian estimation. For now, you have to set that parameter. That's an assumption you make. So this goes into the calculation of each of those higher order statistics. And then, then you can basically come up with those statistics. So let's define something called inertia. It's a very simple one. So we look at the history of identical statements. So let's say you take this light red row here, actor 3 refers to concept 2 in a positive way. Then for inertia, we basically count how often did that thing happen in the past. So we go over the event sequence in the past, and we count how often did that happen. And you can see that in the first row, it's dark red. So that's the same actor concept agreement combination. So that happened one time. So we downweight this basically with that decay function. And that's basically our count, our covariate that we include. And we can have actor activity. That's basically, for this case, we count how often that particular actor was active and included as a covariate to account for actor clustering or differentials in how active different actors are. If we don't have covariates that would account for this, like exogenous covariates, this can become an endogenous covariate as well. We do the same thing with concept popularity. So if a concept has been really popular recently, we can just count how often that concept was used recently. So in this case, concept 5. And we can downweight it each time with that decay factor and include it as one count, basically, at that time point. For each combination of actor concept agreement, we do that. And then bonding, the one that I showed you on the previous slide. So you can write them down in maths if you want, but it's just basically what I showed you on the previous slide. So you can just go through the history and you can, over all actor and concept combinations and agreement combinations, you count how often this happened, you downweight it each time using that decay, and that forms your bonding or positive reciprocity covariate that you include. Repulsion or negative reciprocity in the same way. Exogenous covariates can be included by just multiplying the edge weight. And then you estimate the model using conditional logit, and you get coefficients out of it. So in this case, for example, we would see that bonding has a positive coefficient, Bonding times, is it a government actor, has a negative coefficient? So that means positive reciprocity. So this coalition formation process is indeed happening in this way. But if it's a government actor, then they're less prone to form these coalitions. They want to stay neutral in the middle. My interpretation of it, at least, right? And then bridging, also has a positive coefficient, and government actors do this more often. They seek to establish compromise solutions. Bridging. Messed this up here. Oh no, this is the full model and no interaction effect. Sorry. No, government actors also do that less, actually. Yeah, got it wrong. Yeah, and then repulsion also, repulsion government. So same profile here. And then those other mechanisms I talked about: inertia, actor activity, concept popularity, actor type. Okay. We can also generate the marginal effects then for those three main mechanisms that I think guide coalition formation, or at least three important ones. Of course, that's still something that can be improved. This is just a starting point to show you, well, this is how we can model this using basically regression analysis without violating the IID assumption that's so often violated, because these are conditionally independent if we properly model past higher order effects. And then we can build on this basically and improve our theory on how this happens. This is the first foray into theorizing about how this works. Then you can look at these things also over time. So this is basically at any point in time for the last 500 events, what would be the coefficient? So we re-estimate this all the time. And you can see there's a little bit of heterogeneity, but they are more or less firmly in the positive range, these coefficients across the different time points. There's more uncertainty. You see the uncertainty regions here in the beginning because there are fewer data points. So log odds of this particular actor concept agreement thing happening if we it's standardized in some way if we increase the bonding coefficient by 1 unit. But that, of course, depends on the half-life parameter of how the coefficient is constructed. So it's a bit tricky to interpret, really. It's more so the absolute level, we can do it if we want to, but it involves some kind of thinking hard about it. It's more important to see that it's kind of in the positive range across the whole time range here with very few exceptions. So it's not like some crazy heterogeneity that kind of jumps up and down or something into the negative range. So we do see some episodes where the coefficient is statistically indistinguishable from 0, and that's highlighted here with this gray background color. So that's more the case for bridging, though, than for the other ones. So just to give some additional kind of context into how to interpret this, like how homogeneous those coefficients are really, if we take that debate. Yeah, and then you can also look at the prediction performance. You can take that model and you can predict into the future, and you can then assess how well did I do. Predicting the correct actor. That's the first two columns here on the same day. That doesn't. I mean, it works reasonably well, but not super well. Well, plus minus 5 days, plus minus 10 days, that gets easier. That way you guess the correct person or organization to speak. Same thing with concepts. And then the task, of course, becomes less trivial if you want to guess exactly which actor talked about which particular concept in which way. So basically that goes from a very, very low percentage of correct predictions to something about 50% correct if you allow for plus minus 10 days during the prediction interval. So yeah, you can basically try to predict the debate forward, and I think I see some potential use for this. And if I was an interest group and I wanted to know what to say next, I could run some sort of counterfactuals to see, okay, what gets me the highest probability of the debate developing in this direction or that direction. Right? So we could potentially think into that direction. Yeah, so my former PhD student actually under my supervision wrote a paper in political analysis on how to sample a forward prediction and then also a goodness of fit assessment for these models. So this could actually work pretty well. Yeah, so I left another section here, but I was not planning to present it because I realized that would be too much. So it's basically just to say that there is a ton of additional new work on exploratory methods, on what to do with those debates. So I'm not going to present this in any detail. I'm just going to, for 3 minutes, rush through the main important visualizations here just to show you what else I'm working on. There is work on polarization. So we operationalized polarization, and then I designed a genetic algorithm to optimize, to identify, so to measure what the level of the extent of polarization in a debate is at any given point in time. And then we smooth it over time. And that leads to curves like this, for example, where you can say as an output of that genetic algorithm, how polarized the debate is at any point in time. Yeah, so there's a different debate here. This is for climate change, but you see this curve here that expresses more polarization or less polarization. So how polarized are those coalitions? Yeah, it's just some diagnostics. Another area is ideological scaling using item response theory. So basically, this is the minimum unit pricing and the sugar tax debate in the UK, both lumped together here. And you can estimate ideal points for the different actors on a one-dimensional scale or even two-dimensional scale if you want. And you can see here in the sugar tax debate how the charities and scientists and government advisors and NHS are sort of on the left spectrum in one coalition, and in the other, on the other side of the spectrum, so that up here on the right side of the spectrum, you see manufacturers of drinks, for example, and sugary products, private think tanks and retailers, and you get some HPD interval, so like a confidence interval in the Bayesian sense, basically, right? To give you the uncertainty around, or the distribution around those estimates. So that way you can basically figure out how extreme within a coalition or moderate within a coalition is an actor. And also extend that to the concepts using discrimination parameters, and locate basically those concepts also on that dimension. Another thing I'm working on is detecting phase transitions and states of a debate. So this is entirely screenshotted from a paper by a colleague who's applying these sorts of methods in a very different context in different other kinds of networks. But I want to apply this, perhaps modify this and apply this to discourse networks. I've already started doing that. So the idea is that there may be heterogeneity over time, but there are also certain commonalities between different time points and how the coalitions are structured. And so what you could do is you could cluster all the different days or time points, like the networks. You can create a network of, I don't know, 200 or 300 days. You can move it forward by 1 day each time. Then you get lots of consecutive networks. Then you can cluster them. You can say which ones are more similar to each other than others in terms of what those coalitions look like. And then you can interpret these different clusters as phases or stages in the debate, right? So, for example, in that pension debate in the beginning, there was like one coalition, it was dominant. There were no other coalitions. You would identify all of those time points together as one part of the debate. And then it would switch to a different cluster or solution, right, with the polarized debate that would go together as one phase. Like you can imagine it's like a phase diagram, right? Like this state dynamic diagram you see here in the bottom row. And then at some point it would go into a third stage where you again have one dominant coalition, but a different one. And it could also go back into a previous state, for example. So you can observe these phase transitions between different kinds of ways in which the debate is structured. Yeah, so you can cluster it like this. And then I'm also working on a method for identifying which concepts together lend their cluster structure to the actor network. You can, of course, just say, okay, if I take one concept out, then the debate looks very different suddenly, the network looks different. But taking one out is not sufficient. You have to take multiple out to see the joint effect of taking them out. And so the goal is basically to find the set of concepts, if you take them out together, that leave something that doesn't resemble the debate at all. Yeah, so those that basically form the backbone of the structure of the debate that you identified using cluster analysis. So in the pension debate, for example, I can reduce the set of concepts to 7 concepts that create an actor congruence network that looks almost like the original one, which is a very parsimonious model of the debate at the conceptual level. So I wrote this simulated annealing algorithm. Don't worry, I'm not going to go into too much detail here. And then some diagnostics of that optimization procedure, and then you can see the complete network on the left, and you can see the backbone network. So that's based on only 7 concepts out of the 57, but it looks almost identical. It's pretty cool. And then the redundant concepts, those are the remaining 50 concepts. So you see they don't really resemble the debate anymore. And then the final thing I'm working on right now is to make the coding framework more flexible. So it's already possible to define your own kinds of statements. You can define your own variables. For example, the narrative policy framework, it's another policy theory that contains things like the narrator or actor who speaks, and then a victim in the story, and a villain, and a hero, and a policy solution, and a plot, right? All these different things can pop up. Now that's not very well represented by those things that I used to define the coding framework. You can now already define your own coding frameworks like the one you see here, but I'm now making it more flexible so that you can add multiple victims, for example, or multiple actors into the same statement. And I'm also defining this in a more flexible way for the analysis so that you can define ontologies. So you can define basically how the different variables should be interrelated to form the empirical network, and in what ways. So each tie in this ontology corresponds to one set of settings in the export function. So you can combine them in very, very different and arbitrary ways. You can define different ontologies and then export an empirical knowledge graph or network that is more complex than what you can export right now. And then you can cluster it, or you can work with it in some way. That's it from my side for now. And then we can go into the discussion. Thank you.